terminal velocity is that uniform velocity at which it travels after where the force of gravity balances upthrust and viscosity. At that point, our acceleration will be zero because it's going to be moving with the terminal velocity, which is a uniform velocity. And you know, when you have uniform velocity, there's no acceleration, right? So at that point, viscosity is equals to the gravitational force due to the mass of the body minus the upthrust. When a ball is dropped inside a liquid container, depend on the viscosity of the liquid. And when we talk about viscosity, is the degree of coercive force that exists between that liquid that affects the way the liquid flows, or that affects the forces, the intermolecular forces between the liquid. A viscous liquid is a liquid that does not flow easily, while a non-viscous liquid can just flow easily. For example, engine oil is very viscous, while water is less viscous. All right, now, when you drop a metallic ball, this is a container and it contains liquid. So when you drop a metallic ball into this liquid, immediately it drop, it's coming with a force mg. That's the force that is coming with. Now, when it enters this liquid, it's going to experience upthrust, U. And then it's going to experience viscosity, force due to viscosity, V. All right? So, what will now be, it will accelerate. It will be going down until you get to a point where there will be no more acceleration. It will be going gently. So, the force at which it's moving is going to be mg minus u minus v is equals to ma. When you drop it inside, the total force resolution, because upthrust is against it, upthrust, viscosity is against it, viscosity, and it's coming with its own force, F, mg. So the total force, final force of it coming in is mg minus u, upthrust, minus v, viscosity, will give us the force, mass times acceleration, where the thing is going, the acceleration of the metallic ball in the liquid to go, then get to a point where all these forces will balance out. At that point, it will be moving with a uniform velocity. Our acceleration will be zero. So this uniform velocity at which our acceleration is zero is called terminal velocity. And at terminal velocity, acceleration is equal to zero. It then means that what? mg minus u minus v is equals to ma. M times 0 is 0. So when you move u and v to the other side, it implies that mg is equals to upthrust plus viscosity. Now, you can use this formula to get upthrust. You can use the formula to get viscosity in a liquid. How do you do that? It then means that viscosity is equals to mg minus upthrust at terminal velocity. So once it has experienced a terminal velocity is that uniform velocity at which it travels after where the force of gravity balances upthrust and viscosity. At that point, our acceleration will be zero because it's going to be moving with the terminal velocity, which is a uniform velocity. And you know, when you have uniform velocity, there's no acceleration, right? So at that point, viscosity is equals to the gravitational force due to the mass of the body minus the upthrust. Or you have it this way: the force is equals to what? The gravitational force due to the mass of the body in the liquid or fluid is equals to upthrust plus viscosity. At this point, when the balance is going at a uniform velocity and acceleration is zero. All right, at this point, that uniform velocity is called terminal velocity. I hope this has helped to explain terminal velocity and viscosity in a liquid. Thank you and bye.